Hello friends, today we are going to see the KMP string search algorithm. So let's see. So this is the text and this is the pattern. This pattern we have to search inside this text. And after searching this pattern in this text, we have to return the starting index of this pattern in this text. For example, BCFG is here. So you have to return this starting index of B. Let's give index 0, 1, 2, 3, 4, 5, 6 and 7. So your answer is 3 because this pattern is starting at index 3. Okay. Now let's first see how to search this pattern in this text using the brute force method. And then in that brute force algorithm, we will see how the KMP algorithm reduces the time complexity. Okay. So let's start to see the brute force algorithm at first. So in the brute force algorithm, the starting position, we first consider it as the 0th index. We just suppose that the starting position of this pattern is the 0th index. Okay, and we initialize I to the starting position and J to the starting of the pattern. Okay, so let's do it. So compare A and B. So A and B, they don't match. So we come to know that this is not the correct starting position. Okay, so we move the starting position ahead and we initialize I to the starting position again and J to the starting of the pattern again. Okay, so B and B, they match. So because they match, we will move I and J one position ahead. Okay, whenever a character matches, we have to increment I and J both. Okay, now C and C match, so increment I and J. So I will be incremented and J will be incremented. Okay, so B and F, they don't match, so the pattern is not matching completely here. Okay, so we come to know that this is not the correct starting position. Yes, so whenever we come to know that some position is not the correct starting position, just move the starting position ahead and again initialize I to that starting position and again initialize J to the starting of the pattern, because from that position we are again going to match the complete pattern. Okay, now so C is not matching with B, so this is not the correct starting position. So we will move ahead the starting position. I will be pointing to the starting position and J will again point to the starting of the pattern. Now B is matched with B, so increment this I and J. Now again C has matched with C, so increment I and J. F is matched with F, so increment I and J. Okay, G is matched with G. Yes, so this is the end, means we have found out the whole pattern. The whole pattern has matched inside this string, so we will return the starting index, that is 3, as the answer. Okay, so this is the brute force algorithm, and now we will see the KMP string search algorithm. So let's see the KMP algorithm now. So this is the text and this is the pattern, and this pattern we have to search in this text. So similar to the brute force algorithm, we will first consider the first character as the starting position of this pattern in this text, and we will initialize I to the starting position and J to the starting of the pattern. Okay, so let's compare I and J. So A is equal to A, so we will increment I and J both. So I is incremented and J is incremented. Now compare C and C, they are matching, so we will increment I and j. Again B and B is matching, so I is incremented and j is incremented. A and A is matching, so I is incremented and j is incremented. Now C and C is matching, so I is incremented and j is incremented. Now here X and D, they don't match. So whenever a character is not matching, here the KMP algorithm makes the difference. So the KMP algorithm makes the finding of the next starting position easier and it reduces the time complexity of that procedure. So let's see how does it do. So if we continue by brute force algorithm, then what we would do here is we will just move the starting position to the next character, then we will initialize I to the starting position and j will be initialized to the beginning of the pattern. Then we will compare A and C, they don't match, so we will conclude that this is not the correct starting position and we will move the starting position ahead and we will initialize I to that starting position and j to the starting of the pattern again. So A and B are not matching, so we will come to know that this is not the correct starting position and we will move to the next starting position and we will initialize I to that starting position and j to the starting of the pattern again. Okay, now A and A are matching. This means that we have found the correct starting position here. So this index is the correct starting position. Okay. Here we have taken these two comparisons to find the correct starting position. We compared A with C, then B, and finally we found out the correct starting position. These two comparisons are unnecessary. If we use this KMP algorithm, then we can avoid these two unnecessary comparisons and we can directly find out the next starting position. Okay, so I will tell you how. I will just clean it. So the mismatch had occurred at X and D. Okay, as you remember, the mismatch was at X and D. Before X and D, all characters had matched. Okay, now when the mismatch occurs, the KMP algorithm observes the substring before the mismatching character. So here in this pattern, D is the mismatching character and the substring before D is ACBAC. Okay, and for that substring the KMP algorithm finds out the proper prefixes and suffixes. Okay, now see here what are the proper prefix of ACBAC? I will write here. So the proper prefix are A, then AC, ACB and ACBA. ACBA. So these four are the proper prefix. And what are the proper suffix? So suffix are C, AC, then BAC and CBAC. Okay, now what it does is that out of the prefix and suffix you have to find out a substring which is the suffix and also the prefix. Okay, in this case AC is the string, this AC is the string which is the suffix as well as the prefix. So you have to find out the longest common substring in the prefix and suffix such that it is the suffix as well as it is the prefix. Okay, so in this case AC is the suffix and prefix. Now you can see this total substring matches with this substring, because when they have matched, then only I and J have reached X and D respectively. If they don't match, then we would not reach X and D. So we know that these two substrings are equal. This means that this substring also contains the suffix, which is the prefix as well. Okay, so I can now say that the prefix in this substring, that is this AC, this prefix is the suffix in this string. Okay, this prefix is the suffix in this string. I can say that. This means that when our J is pointing to the first character of the pattern, again when a mismatch occurs, and I is pointing to the next starting position C, as you remember, at that time there is no need to compare this A with C and D, because we know that this prefix is directly present as suffix here. So we can directly match this A with this A, and we can directly jump to this location and conclude this location as the correct starting point for the next comparisons, or for looking this pattern in the text. So this is the correct position, or this is the correct starting position, next starting position. In other words, we can say that A will directly match to this A, and we can conclude that because this prefix is the suffix here. Okay, so in this way the unnecessary two comparisons, this C and B, are saved. So we don't need to compare these two characters with A. So we save these two comparisons. Okay, now the next thing is that along with the correct starting position here, we also come to know that the length of the prefix here is 2. The length is 2, and this prefix exactly matches this suffix, and the length is 2. Because they exactly match, so the lengths are same. So we directly skip these two characters. We directly skip these two characters because we know that they are matching. So we skip the two characters. Here also we skip these two characters, and we directly jump to B, and we point B by J. So J directly points to B, and I directly points to X. This means we have found out the correct starting position, and we have skipped two comparisons also. Means we don't need to again compare AC because they are perfectly matching, and we know that. So I directly jumps to X and J directly jumps to B, and we will directly start comparing from X and B, and we will start comparing X, B, then A, B, C. Okay, so this is how KMP algorithm saves the two comparisons at first, and then another two comparisons in this case, because the suffix length is 2. If the suffix length is S, then it will save 2 plus S comparisons. So these two comparisons are not needed. We can directly jump to the next characters to compare. So this is where the KMP algorithm reduces the time complexity, by reducing the unnecessary comparisons. So let's continue. See, X and B, they don't match. So when X and B don't match, then you have to follow the procedure. So as X and B is not matching, so now again check for the substring behind B. Okay, so what is the substring AC? So is there any suffix which is a prefix? No, it is not there, because the string contains unique characters, so there is nothing common between suffix and prefix. So When there is no suffix which is the prefix, when this is not the case, so in that case you can come to know that this is not the correct starting position. Okay, and you take the next starting position as A, means the next character to I as the next starting position, and initialize I to that character and J to the beginning of the pattern again. Okay, now compare A with A. Yes, they are matching, so increment I and J, they are incremented. Now compare C with B. So C and B are not matching. So by the rule, you can see the substring before this unmatched character. So what is the substring before unmatched character? That is A. So there is no proper suffix which is also the prefix in this substring. Okay, because this is a single character, so there cannot be a proper suffix which is the prefix as well. So in this case this condition fails. So as I have told you, you can directly move the starting position to the next character, that is I plus 1, means the next position of I, and initialize I to that character and J to the beginning of the pattern. Okay, so compare A with C. Yes, A and C are not matching, so we can move the starting position here. As this is the start of the pattern, so we cannot look for the substring behind A because this is already the start of the pattern, so we can directly move to the next position as the starting position and initialize I to that position. So now, and J will be again initialized to the starting of the pattern. Okay, compare A with D, not matched, so move the starting position ahead. So I is pointing here. Now A is matching with A, so increment I and J. Then B is not matching with C, so again check for the substring behind C here. So there is no suffix which is the prefix, so they don't match, so we move the starting position to the next character of I. So and we point I to that starting position, and J will again come to the beginning of the pattern. Okay, now compare A with X, they are not matching, and as this is the first character, we cannot look for the substring behind this character, so we directly move the starting position ahead. Okay, and we point I to that starting position. Now compare A with A. Yes, they are matching, so increment J and I. Compare C with B, they are not matching again, so as they are not matching, we will look for the substring behind C. There is no suffix which is the prefix, the same thing, so we directly move the starting position ahead and we point I to that starting position, and J again comes to the starting of the pattern. Okay, so now check, C is matching with A, no, so we move the starting position ahead here. Okay, and we point I to that starting position. So D is matching with A, no, so we move the starting position ahead because A is not matching with D. So now the starting position is A and I is pointing to the starting position. See, A is matching to A, yes, so we increment J and I as well. Okay, again C is matching with C, yes, so we increment J and I. B is matching with B, so we increment J and I. A is matching with A, so we increment J and I. So in this way, all the characters you can see D, A, B, C, Y, D, A, B, C, Y are matching. So I will reach Y and J will reach Y in the pattern, because the whole pattern is matching, you can see. Okay, so as the whole pattern has matched, now we have to return the index of the starting position. So this is the starting position and you have to return the index of this starting position as the answer. Now in this case, what will be the index? You can see 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So 17 is the starting index of this pattern in this text. Okay, so this is the way this KMP algorithm works. Now as I have told you, you have to find the prefix and suffix. But while running the algorithm, while writing the code, you don't need to find out prefix and suffix, because now I am going to tell you the shortest way, the shortcut to do this prefix and suffix. So let's see how do we do that. So the main use of this prefix and suffix is to find out the next starting index, means the next comparison starting point. As you remember, in this string, when we had a mismatch at D and X, X and D were not matching, that time after doing all the procedure, what we got is the starting position in this pattern, that is J was pointing to B and I pointing to X. So we skipped this comparison AC with AC and finding out the starting position of A. We skipped these 4 comparisons and we directly went to an index here, from where we would directly start to compare the characters, assuming that the previous characters in the pattern are already matching. Okay, so the main purpose of finding this prefix and suffix was to find out the next comparison starting index. So I and J are comparison starting indices here. Okay, so now I will tell you what is the shortcut to do that. Okay, so for that we will initialize an array for this pattern. So I will make the array the cells 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So this is the array, and this array will store the values, will store the indices in this array, and these indices will indicate the next starting of the comparison, means the next starting indices of for the comparison. So for the first character always the value is 0. Okay, and we will now give the indices 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Okay, these are the indices for this array, and each cell in this array is representing each character of the pattern. Now, so the value for the 0th index is always 0, because that is the first character. Now I will tell you the reason of this 0 further. So now initialize I to the first index and J to the next of I. Yes, so now compare I and J. So what is the character at I and J? So the characters are A and C. So compare A and C. A is not equal to C. So because A is not equal to C, we have to write 0 in the cell for C. So 0 in the first index as well. Now J will increment. Because they have not matched, so I will remain at its position and J will increment. So B and A, they don't match. So because J is not matching with I and I is at the 0th index, so now we have to write 0 in this cell as well, and we will increment J. So A is matching with A. See here, A is matching with A. In this case, you have to go to the index I, and index I is 0, and you have to add 1. So 0 plus 1, I plus 1 here, I plus 1. So 0 plus 1 is 1, and you have to write that at the jth index. So that is 1. Okay, I will tell you the meaning of this one as we go further. Yes, just stay tuned, you will understand the whole array perfectly. Now after they match, A and A is matching, we have to increment I and J both. I is incremented, J is incremented. So now C and C are matching. So go to the ith index, that is 1. 1 plus 1 is 2, and you have to write that 2 at the jth index. Okay. Now the meaning of this 2 is that you must be remembering when a mismatch occurred at X and D. Okay, we went to C for the substring behind D. This was the substring behind C. This was the mismatch, and this was the character of mismatch, and this is the substring behind that mismatch. And in this substring, the length of the longest suffix, which is the prefix, is 2. That is the meaning of this. Got it? And the another meaning is, if a mismatch occurs for the character D, for this character, if the mismatch occurs for this character, then you have to look for the previous character, and the value for the previous character, that is 2 here, and this index 2 is the next starting position for comparison in this pattern. If you remember, after this mismatch, we started to compare X, this X, and we pointed X by I, and B. We started comparing B and X. We skipped AC. We started the comparison from B in this pattern and X in this text. Okay, so this means that we have to start the comparison from the index 2 in this pattern. Okay, this is the meaning of this value. Now this 1, you can see this 1 points to the character A, and if you see the substring behind A, then in this substring behind A, this substring, the longest suffix which matches the prefix is of length 1. And the another meaning is, if a mismatch occurs at a character C, then go to the previous character here, that is A, go to its value, that is 1, and 1 is the index in this pattern from which you have to start the next comparisons. But in this case, we did not find a mismatch for A. We directly found the mismatch for D and X. So we went to C and the second index, and we started the comparison from the second index, that is B and X. X is the index from where the mismatch occurred. So we continued from that index, and the index in the pattern is 2, which is mentioned for the previous character of the mismatching character. Okay, so this is the reason for this array, and we will pre-build this array for every running of the algorithm. So after we pre-build this array, then we don't need to find out any prefix and suffix. We can directly jump to the locations of restarting the comparisons. Okay, let's go ahead. So here C and C have matched, so we have to increment I and J. So I is incremented and J is incremented. So you can see. So again B and D are not matching. So when B and D they don't match, you have to follow a tricky technique here. So you have to go for the previous character of the ith index. So the character for ith index is B and the previous character is C. So for C the value is 0. So at this time you have to shift I to the 0th index. So you have to shift I to the 0th index. So the 0th index is here and the character for 0th index is A. Then you have to compare the character at this index I, that is A, to the index J, that is D. So here A and D, even they don't match. So you have to write the value of the ith index, that is 0, here at the jth index. Now you will ask me, previously when we had matched here I was here and C, J was here, so we had matched A and C, or for example when I was here and J was here, we had matched A and B. At this time I had directly written 0 here. So I had done that because I cannot jump previous to the first character. But at this time when I was at B and J was at D, I could make I jump to the previous characters. So I made this index I to jump to the previous characters and checked D with the previous characters. So you will understand it perfectly further. Now I was here and J was here, so the value for the index J is 0. Okay, so now again J will move to the next character. So here A and A match. So when A and A match, you have to, as you know, you have to get the value of the ith index, that is 0 plus 1. So here the value for ith index is 0 plus 1, so the value is 1. Okay, and when a character matches, when two characters match, you have to increment both I and J. Okay, now C and B, they don't match, so you have to look for the previous character of ith index. So ith index is C and the previous character is A. So the value of previous character is 0. So I will jump to the 0th index. So I will jump to the 0th index. So the 0th index is here and the character is A. So now A will be matched with the jth index, that is B. A and B, even they don't match. So I will directly write this 0 here, because further I cannot jump now. Means I cannot jump behind the 0th index now. So I directly write this 0 here. Okay, now I was here. See, as the characters didn't match, only J will increment. A and C, they don't match, so 0 will be written directly here. Okay, now, so as the characters don't match, J will jump, means J will increment. So A and Y, they don't match, so I will write 0 as it is here. So this is the way how we can prepare this array, means we can pre-build this array, which will help us in finding out the next starting comparison starting positions. So this is how KMP algorithm works, and in my next video I will tell you how to build this prefix array by taking another example so that you can completely understand the process, and I will solve the KMP algorithm example, that is finding the pattern in the text, again with a different example. Hey friends, please subscribe to my channel as I post algorithm videos every day. And if you want a video on any particular topic, then please mention in the comment below. Thank you.